Hi everybody, welcome to the Manifold channel. Today we're going to take a look at costs and paths in our continuing comparison between Manifold System Release 9 and Esri's ArcMap with Spatial Analyst. We're comparing the performance of the two different products, how they do parallelism, and the workflow. What we're looking at right now is the ArcMap desktop, and this has Spatial Analyst installed, which we can tell by clicking open the catalog and seeing the various tools here. ArcMap desktop, as we're looking at it right now, is we're looking at $5,250 per seat worth of Esri software. That's $2,750 for ArcMap Standard Edition, plus another $2,500 for Spatial Analyst. We're first going to do the equivalent of cost backlinks, cost distance, and cost allocations, and then we'll do a path distance. We're going to use this raster here, which is Central Florida, about 5,300 by 5,300 pixels. It shows the Lake Wales Ridge region in Central Florida. Now, we'll first do this in a Manifold system because Manifold is way faster than Arc. And just in case people run out of patience, waiting for Arc to do its thing, we'll do all this first in a Manifold, where a Manifold takes 3 to 4 seconds to do each of the geoprocessing tasks, which that Arc will later take 2 minutes to do. So let's get these going. We're using exactly the same raster right here, Manifold System Release 9. Typically sells for under $500 per seat. This particular package was acquired for $475. All right, so let's get right to it. The equivalent of the toolbox in Arc and Manifold is this is the transform pane, where we have all these different transforms, and there's so many of them that to reduce them down to a manageable number of transforms to pick from, is we can enter something in the filter box here, so we can pick these right here. The first one we're going to do is the closest path direction. We're going to use the Florida drawing, and the context is grayscale. I'm going to reduce simplify the name, because the default names are a little bit long for my taste. So I'm going to click OK, and now here, let's set it to running. Click Add Component, and it's off to the races. It's going to take it 3 to 4 seconds, and it's done already. It's that quick to do something in Manifold, which takes about 2 minutes in Arc. What it did, it created this raster right here, which shows the direction, by closest path from each of these raster points to those dots. Manifold does not default format using pretty colors the way ArcMap does, but that's easy enough to do. I'm going to do a trick here to copy a style that I already created. It's a style that's designed to match Arc exactly. So what I did is I copied that style. I'm going to paste it here into a style pixel property. Got to spell that right. And Control V to paste. Click OK. And there. This is a style which matches exactly what Arc is going to do for default, so it makes it a straight-up comparison. If we were willing to use one of the Manifold styles, I could have done that with a point and click in the style layer, but in the style pane. And so instead, I'm just going to do that copy and paste trick as we proceed. Fine. We just did what's equivalent to the cost backlink. Let's do the closest path distance, which is that. Again, I don't want to use equal cost because I want the costs of each of these pixels to factor into the closest path calculation. That's going to make it exactly like Esri's Spatial Analyst cost distance calculation. Again, I'm going to simplify the name. I don't like long names, so I'll make it a little bit shorter. And now I'm going to click Add Component. And once again, this is going to take 3 to 4 seconds to run, and it's done. It's that quick. And what it did is it created this image right here, this Manifold called rasters images. That's kind of an attempt to appeal to people that may not be so technical. But I call them rasters because that's what they are. And here again, let's use that trick to copy the equivalent of the Esri style. Copy, cancel. Then here into the properties, again I'm going to add style pixel. And here, Control V, and click OK. And there. And what this shows is the distance from each of these, for each raster pixel, it picks what by cost distance is the closest green point, and then it shows by color coding the path distance in terms of cost to that dot. If you're a spatial analyst guy, you know exactly what that means. All right, now for the next one, what we're going to do is we're going to do the closest path source. Again, I'll use Florida drawing. Again, it's going to be the context is this grayscale. Again, we will reduce the name to something. Simplify the name to something smaller, click Add Component, and once more that's going to take 3 to 4 seconds It's actually doing this in real time, by the way. This is not some kind of trick or anything like that. It really is calculating it right here, and it's creating this image, closest source path source image, and let's get that as recoloring here. Copy the style from the style pixel property there. These are all runs that I did before, which were manually styled so they look exactly like the Esri ones, and that's where I'm copying the properties from. And what these properties are, style pixel, is they are simply JSON strings. I mean, that's how you define a style in Manifold. They're all JSON strings, and click Edit. You can see what that looks like. It shows what all those values are, and there we go. There it's done. And what's nice about this is that everything in Manifold is exposed in the table. So if you say you wanted to copy this style to like 100 different components, well, that's easy to do because you can just simple matter of copying it throughout the table, where all these things are kept resident by whatever components you want to have that style. So that can be done in just a heartbeat. Now for this last one, which is going to take a little bit longer in Manifold, it's going to be the closest slope path distance, and that's a sophisticated deal. We're going to start from sources, which means we're going to start this and go outwards. And what this does is that on the fly computes a slope for each of these raster pixels, and then it reckons the cost of the path by the direction. And so if you're going downhill on the slope, that's cheaper than if you're going uphill on the slope. So it's not just choosing whether it has slope or not slope, it's considering how much slope and in what direction it is, whether it's uphill or downhill. So again, we simplify the name, click OK, click Add Component to make it run. This takes 12 minutes in ArcMap. In Manifold, it's going to take it 8 to 9 seconds, which after you're doing stuff that only takes 3 seconds or so seems like a long time, but there it is, it's done again. You won't believe how long 12 seconds seems to take in such circumstances. So let's drag and drop that into the map again, and close the slope path distance again. We will copy the Esri coloring from the style pixel property here, copy, and paste it into this guy. I want to emphasize you don't have to do this manual stuff if you're happy using the manifold styles. You can just point and click, and it'll do it in just a couple of clicks. Okay, so there you go. So this is the distance from each raster pixel to what is the least cost, closest by least cost path, green pixel, green dot, green point, reckoning going downhill on slopes as cheaper than going uphill on slopes. A lot of this is flat area here because we're looking at the Lake Wales Ridge region in Florida, which although it's called a ridge, Florida is still pretty darn flat, so there isn't a whole lot of differentiation. Now that we've seen how to do all that in Manifold, let's see how we do all this in Arc. And the first thing I'm going to do is I want to make sure that in my environments that the parallel processing factor is 100%. That's important because many of Esri's spatial analyst tools have been parallelized. What we saw Manifold doing, by the way, was 100% parallelization. It's Manifold ran 48 threads all the time. In fact, if you want to rerun any of these, what the heck, let's just rerun it on Florida. I'm going to do this one right here. And what we did, the closest path slope distance, that's it. And start from source. So options, simplify it. It's going to create a duplicate of this with a name too. Now I'm going to click Add Component. And while that's running, you can see how Manifold is actually launching all 48 threads. We're working on a 24-core Threadripper here, and that means it can run up to 48 threads, and you can see how it just popped that open instantly on all 48 threads during the 8 or 9 seconds that it was running. It actually used all those 48 threads. If you want to see how long Manifold takes, by the way, you can scroll into this log window, and you can see that took 8.4 seconds. Before it took 8.4 seconds also. Before that, the closest path source was 3.6, 3.7, 3.5. So in that 3 to 4 second ballpark, with the 8 to 4 second ballpark for the bigger slope direction computation. And like I say, using all 48 threads. Here in Arc, when you set the parallel processing environment to 100%, that lets Arc make its own decisions as to what it's going to do. And the first thing we're going to do is we're going to do a cost backlink. Where is it? There it is right there. We're going to use the drawing as our feature source data. We're going to use the Florida grid as our input cost raster, and then we're going to click OK. All right, now we can kind of sit back here and take our time, because Arc is going to take a long while to do this. It's going to take 2 minutes. And 2 minutes seems like an eternity, even though, with this narration going in the background, I'm going to try to, keep it as entertaining as possible for people that are watching this video. Let's talk about the things that are cool about ArcMap. The first thing that's cool, that I like a lot, is how it reports the what it's doing here and all the results. So this is great for collecting metadata. You can see what the inputs are, you can see what the environments are, and you can see what all the messages are, exactly when it started, exactly how long it took. It's distributing the operation across 9 parallel instances. What's going on here is that Arc itself is actually dual-threaded. People say it's a single-threaded application, but that's not quite right. It's actually dual-threaded. It can run one thread in the foreground, so as you can see here, we can do things with the user interface while it's running something else in the background. And this is what it's running in the background right here. It's the cost backlink geoprocessing module, the geoprocessing tool. And these tools have been parallelized, some better parallelized than others, some to greater or to lesser degree. This particular tool can do up to 9 threads. Now, why did it decide to use only 9 threads when it could have used 48 threads? I don't know, but it calculated that to be optimal, and we're not going to argue with it. We're just going to let it do its thing. So we should be getting pretty close here. And at any second, what it's going to do is going to create a raster that's going to show that direction, and it's going to be equivalent to the closest path direction raster that we created in Manifold. Keep in mind that we did that in Manifold in whatever it was, 3.6 seconds or something like that. And here, I don't know where we're up to, but it's going to take us nearly 2 minutes in ArcMap with Spatial Analyst. Well, what else can we say positive about ArcMap? I like this system here, the way it does it, a lot better than the way ArcGIS Pro does it. ArcGIS Pro, you kind of got to pick individual things. You can't see them all at once. You got to sort of hover the mouse or click on it, and it pops up in the pane. There, it's done. And that took 2 minutes and 6 seconds. It's usually faster than that. So, maybe this whole raster wasn't in Windows Cache or something like that. I don't know. And here's the image that it created. As you can see, if we can compare that to the Manifold image, it's the same deal. Same computation, just that Manifold did it in 4 seconds and for $4,800 less in cost. This is something I do like a lot about Arc, by the way. It automatically assigns this palette. Let's get the second one cooking, by the way, while we're at this, so we can talk more about the palettes while Arc is working. We're going to do a cost distance, and the cost distance is right there. Again, for the source data, we're going to use the Florida feature source. We're going to use a Florida drawing. For the input raster, we're going to use Florida grid. And that's it. Off to the races. We can close this and once again open that up, and we can see the messages that it's giving us. And it's decided to use nine threads again. Anyway, one of the things I like about Arc, which is elegant and very pretty, is this how it automatically will pick a palette that is a color ramp and assign it to a raster that it creates. I think that makes life a lot easier. And for example, when it does things like here it is with the Florida grid, it assigned all that automatically. I think it's very nice, and here it did in this raster. Manifold doesn't do that. Manifold do a grayscale deal. If you want to color it, you can color it very quickly, but it doesn't quite yet do something like this, which is nifty. I suppose that'll be added to Manifold in the weeks ahead. Manifold is adding things right now at an incredibly fast rate. Since the build out of the original system, which was mainly focused on the machinery that allows it to do all this stuff in 3 seconds instead of 2 minutes. Be that as it may, how are we doing here on the cost distance? Cost distance is also going to take us about 1 minute and 45 seconds, something like that. It's going through the iteration phase, and that's going to be equivalent to what we saw here in Manifold, like that. That's what it's going to come out doing. I don't want to switch too much because I don't want anybody accusing me of throwing a monkey wrench in the works of Arc. It's really not. I mean, there's 48 threads in this machine available, so when Arc is running with the geoprocessing tool is running with 9 parallel instances, that leaves us with 39 threads that are available to do whatever we want to do with other software. You can play Netflix or whatever you want to do, and that's not going to change a thing. Completion phase is getting done. It's getting close to being done. So soon, this is going to happen. So there, it's done. And elapse time 1 minute 52 seconds. Like I say, it's normally a few seconds faster than that. As you can see, the Manifold image is identically the same. Let's get right to it because we have one more that we're going to do, the cost allocation. And so click here. Going to click cost allocation. The input raster feature data source, again, is going to be the drawing. The input cost raster is again going to be Florida. And let's click OK. This one also is going to take about 2 minutes. So let's continue praising ARC while we're at it. Here again you can see how nifty it is that ARC did this beautiful display. And you can see there's a slight delay here because while it's doing the cost allocation in the background, it's kind of interfering slightly with the foreground messaging. It's working with 9 parallel instances. There, finished drawing at that time. The question that's, I think, on every intelligent person's mind who's familiar with computing when they're looking at this is how exactly is it possible that Manifold is doing stuff in 3 or 4 seconds, which takes ARC 2 minutes. Why we're doing this comparison to ArcMap and spatial analysis is because those are extremely premium products. I mean, they're wonderful products. Esri has incredible amounts of experience. Nobody knows GIS better than Esri. And they put a lot of effort into parallelizing these geoprocessing tools. So how is it that Manifold is running faster? There's a variety of things going on here. The first thing is that Manifold is 100% parallel. Everything that it does, the core application and everything that it launches internally, are all running parallel. And they're using every CPU core and thread that they can, every bit of it. In contrast, what we're looking at here, ArcMap is only dual-threaded. So when it's launching these tools here in the toolbox, some of which have been parallelized, it's sending that data on a round trip from a single-threaded application to a multi-threaded module and then back. And that causes a lot of traffic jams. That's like running for a couple of miles on a 8-lane highway, and then you get to a 1-lane off-ramp, and then you got to wait at a traffic light, and then get a 1-lane on-ramp to get back onto the highway. The highway doesn't help as much as it could, as if there were no single-lane traffic jams on the on-ramp and on the off-ramps. That's the first thing. The second thing, we're getting here to the completion. Okay, it's done. 2 minutes and 1 second. So you can see how that did it, and let's see what the equivalent was in Manifold. There it is right there. You can see it's the same diagram. It said that instead of taking 2 minutes, Manifold took, 3.8, 3.9 seconds. Now, I'm going to launch the last thing we're going to do here, which is the path distances. That's a tricky deal. And the input raster feature source is going to be the Florida drawing. The input surface raster is going to be Florida itself. And here I'm going to input a vertical raster, which you need to do for this thing. And that also is going to be Florida. And we're going to use a linear vertical factor, because it is a linear vertical factor. And we're going to leave these settings as the defaults. They're actually reasonable defaults. And now we're going to click OK and let that cook. Like I say, we're not going to let that run to completion, but because it's going to take 12 minutes. 11 to 12 minutes. Sometimes it's faster, sometimes it's slower. It's also distributing across 9 parallel instances. And what I'm going to do is I'm just going to say a few more words, then I'll pause the video, and then we'll pick it back up when ARC comes back to us. Anyway, the other factors is that, in terms of speed differences, is that ARC doesn't parallelize as well as Manifold. The individual work that Manifold done is parallelized to all 48 threads. That's very hard to do without those threads stepping on each other and to maintain high efficiency. Manifold has a lot of experience with many threads because Manifold is also GPU parallel. If you have a GPU in your system, Manifold will run 1,000, 2,000 instances on the cores on that GPU to do calculations potentially 200 times faster than ARC. I mean, it's truly breathtaking, when that happens, when that makes sense. So all that experience has helped Manifold to create parallelization for CPU parallelism that can actually launch and run on 48 threads, as we saw. That's harder for ARC. They haven't gotten to that point yet. The third and final factor is that the storage technology that's being used here in ARC is GDB. And GDB is kind of a Rube Goldberg storage technology. It uses all those zillions of little files, and it's not particularly parallel processing friendly. Manifold, in contrast, uses a .map format, which is extremely parallel processing friendly. In fact, it was designed to support very high speed, very high performance parallelism with very, very many threads. So when you combine all those factors, that's how Manifold can do in 3 or 4 seconds what takes ARC 2 minutes. In this case, Manifold is going to do in 8 or 9 seconds what's taking ARC 11 to 12 minutes. I'm going to pause right here, and then when it's done, I'll come back. So I'm going to sit here and I'm going to keep watching this thing for another 10 minutes until it's done. And you guys can take a break and you'll see what happens. We'll just slide right through that. So ready, set, pause. Hi everybody, we're back in action, and ArcMap has done its thing. It's actually computed this raster. It took it, let's see how long it took. It took it 11 minutes and 45 seconds, so that's not bad. That's about typical for doing a task like this. As you can see, it created the exact same image that Manifold did, the same raster image, the same calculation. The difference is that Arc took 11 minutes and 45 seconds, and Manifold took, let's see, how long? 8.4 seconds. So that's what, about 70 times faster for Manifold, something like that. Yeah, 70 times faster. All right. I got to tell you, you folks at home watching this on the video didn't have to sit through 10 minutes of waiting, but I did. I sat here and I waited for this darn thing 10 minutes, and I got to tell you, it seems like an eternity when you're sitting at the console waiting for something like that to happen. I guess I should have gone off and gotten coffee or something like that, but I'm not used to that. I'm used to everything happening with Manifold in just a couple seconds. And so when you got to wait for stuff to take 10 minutes, it takes a long time. All this scales up too. Manifold is proportionally faster the bigger the data is. All this happened with a data set that's rather small. It's just this 5,300 by 5,300 image. What do you think that this path distance computation takes when it's, say, 50,000 by 60,000 or 100,000 by 100,000? Manifold can do that. Arc would take hours if it doesn't crash. So, and anything that takes Manifold typically 20 or 30 seconds or even as much as a minute is usually too big for Arc to handle. I say that with respect, but you got to acknowledge the reality of what's going on here. If you're working with bigger data or you're doing more sophisticated tasks, or if you just don't want to sit around for 10 minutes, get a copy of Manifold if you're an Esri person, because the round trip, taking this data, sending it from Arc out to Manifold, doing it in a couple seconds in Manifold, and sending it back for display within, continued use in ArcMap is way quicker than sitting watching ArcMap do its thing. Thanks for watching. I hope you've enjoyed this video, and goodbye from Manifold Land. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.